In this video, you are going to learn how to draw a straight line graph. To draw a straight line graph, only 2 points need to be known. Once these have been plotted, the line can be drawn between them and extended if necessary at both ends. There are three different conditions where you can draw a straight line graph. The first is equation of a straight line is given in gradient intercept form. For instance, y equals to 2x plus 1. From the previous video, we have learned that we can read the gradient and the y-intercept from the gradient intercept form. So from here, we know that the y-intercept of this straight line is 0 and 1. At the same time, we also know that the gradient of this straight line is 2. Well, by figure out the y-intercept, the first point is known to us now. Let's plot the first point on the graph. 0, -1. Now, how can we figure out the second point? We can figure out the second point by using the gradient, and we know that gradient is equals to rise over run. In order to get a gradient of 2, we can rise for 2 units and then we run for 1 unit. So, assuming that this is our beginning point and we can rise for 2 units from 1, which means that we rise from 1 until 3. After that, we run for 1 unit to the right. So now, we have already figured out the second point. If we continue to do this, we can even get the third point. Now, let's use the second point as the starting point. From here, we rise for 2 units. From 3, we go to 5, and we run for 1 unit. So from 1, we go to 2. And this is the third point. From this point, we can draw a line between them. So, this line is represented by this straight line equation, and of course, if necessary, we can extend it to both ends. Extend it. So now, the line y equals to 2x plus 1 is drawn. Thank you. Now, after we have examined how we can use the y-intercept and the simple equation of gradient to draw a straight line graph, let's try one more question. For instance, we have an equation as this: y equals to negative 2x plus 3. Again, from the gradient intercept form of a straight line equation, we know that the y-intercept occur at the point 0 and 3. So let's plot this as our first point, 0, 3. And also we know that the gradient of this straight line is -2. The negative value of the gradient indicates that this graph or the line is going down. And from the simple equation, we also know that -2 is equals to -2 over 1. So which means that we need to go down 2 units and run to the right for 1 unit. The y-intercept will be our starting point. Let's travel now. From here, we go down 2 units. So from 3, we go down to 1. After that, we move to the right for 1 unit. So this is the second point. And of course, we can work out more points by using this method. Again, from here, we move down 2 units. So from 1, we move to -1, and then to the right 1 unit again. Once we have figured out sufficient points for the straight line, we can draw a line to join the points. So this straight line is represented by the equation y equals to -2x plus 3. When necessary, we can even extend it at both points. So this is how we can use the y-intercept form to draw a straight line. Let me repeat again. In order to draw a straight line, when the gradient intercept form is given, firstly, we need to read the y-intercept. And of course, we need to plot the y-intercept after that. Second, we need to read the gradient and integrate the gradient as rise over run. And step 3, we need to figure out the second point. 4, we draw a line to join the points and extend the line if it is necessary. Thank you. So far, we have learned how to draw a straight line graph when the equation is interpreted in gradient intercept form. In this video, we are going to learn how to draw a straight line graph when the straight line equation is not in gradient intercept form. For instance, we have this equation: 3y equals to 2x plus 6. This is unfamiliar for us. However, we can always manipulate the equation so that it can be transformed into the gradient intercept form. To do this, we divide both sides by 3. So we have y equals to 2x over 3. It also can be written as 2 over 3x plus 6 over 3. And 6 over 3 is equal to 2. And now it is very obvious that this is the form which is familiar to us. And from here, of course, we can read the y-intercept. So the coordinates of y-intercept is 0 and 2. Let's plot the y-intercept as our first point, 0 and 2. This is 0 and 2. And also from the coefficient of x, we can figure out the gradient, so that we know the gradient is equals to 2 over 3. This also means that we need to rise 2 units and move to the right for 3 units. So from the first point, we rise 2 units, 1 and 2, and move 3 units to the right, 1, 2 and 3. So this is our second point with the coordinate of 3 and 4. Now we have figured out 2 points, and this is sufficient for us to draw the straight line. First, we join the 2 points, and if it is necessary, we can extend both sides. So now this line is the line represented by 3y equals to 2x plus 6, and let's label it. So this is 3y equals to 2x plus 6. So when we have a straight line equation which is not in the gradient intercept form, firstly we need to transform the non-gradient intercept form into gradient intercept form by manipulating the equation. Once we have figured out the gradient intercept form, we need to read the y-intercept and the gradient in order for us to plot the points needed to draw the line. Thank you. From the previous video, we have learned how to draw a straight line graph when the equation is given in gradient intercept form and also non-gradient intercept form. In this video, we are going to learn how to draw the straight line graph when no equations is given, and the information that you can derive from the question is only the gradient and also 1 point. For instance, draw a straight line that passes 1, 4 with a gradient of negative 2 over 3. In order to draw this straight line, we need 2 points, and 1 point is already known to us. 1, negative 4. Let's plot the first point on the axis. 1, 4. And now the gradient is equals to negative 2 over 3, and we know that gradient is equals to rise over run, which means that we need to go down 2 units, and we move to the right for 3 units from 1 and 4. Go down 2 units from 4, we reach 2. And we run for 3 units from 1, so we reach 4. So this is the second point that we need in order to get this is our second point with a coordinate of 4 and 2. So from here we can predict that the line is going down and it matches the gradient given by the question, because negative gradient is a going down graph. So what we need to do now is we need to join the 2 points and if necessary we can extend the points. So this is a straight line represented that passes through 1, 4 with a gradient of -2/3. Thank you.